Okay, so now I'm going to draw the Lewis structure for HNO3. Okay, so as we get more complicated, it's going to be helpful to just count the number of valence. So we've got 1 here, 5 here, 6 per oxygen times 3, which is 18. So if we sum these now, we get 24 valence electrons that we'll have to keep track of. So again, I'm just going to kind of put things around and hope that maybe this will work out. And if it doesn't, I'll have to fix it later. So connecting up our electrons. And then we can look. So now this guy's got 1, so he's happy. Oxygen has 6 and a full octet, so it's happy. Nitrogen has 5 and a full octet, so it's happy. But then this oxygen here has 6, but not a full octet. And this one here has 6, but not a full octet. So not full. So this can't be the right structure. We could make we could make these guys happy though. So keep our full octet on nitrogen and give 1 to these guys by donating 1 of these electrons over. So then we can form a bond there, giving an octet to oxygen and nitrogen. And then we can give this electron over here, giving oxygen also a full octet. And so drawing this out. Okay, so then now we've got 1 here, 6 here and a full octet, 4 here and a full octet, meaning that this nitrogen has a +1 charge. 6 here and a full octet, and 7 here and a full octet. 7 means that this oxygen has a -1 charge. So now -1 + 1 is 0, so the molecule is still neutral. But everyone has a full octet, so they're happy. So this is likely the correct structure. The only thing to note is that we can draw a resonance structure by migrating those two, and we would get this structure. And I should say that this will further validate this structure, as when you can draw a resonance structure, it stabilizes, or that delocalization stabilizes the structure. And so this is even more likely to be the correct Lewis structure, or the correct molecular structure, I should say. Okay, so looking at this, we get this for the Lewis structure, and so that looks good. So I'm going to say the solution is correct. Okay, that's good.